All right, hey, my name is Mitch, and in this video, I'm going to be giving you advice as to how you can come prepared and succeed in pharmacy school. Now, I'm a first-year pharmacy student, and I'll talk a little bit more about me in the future, but this video is geared towards people who are interested in pharmacy school, and mostly for those who already have gotten accepted and are going to pharmacy school for sure. So this video is going to give you some peace of mind, let you in on things as what to expect for pharmacy school, how you can come prepared, and things to look out for. So that is what the purpose of this video is. Now, if you haven't interviewed yet, or you have future interviews and you want to come more prepared for that, I would highly recommend checking out this video. This is a video I shot in 2019 when I just finished up my interviews. And it is me talking in front of the webcam for 23 minutes, 49 seconds. But what I do is I go into detail about what to expect for interview day, how you can come prepared before, what to do during interview day, what to expect from the interview itself. I go into detail about that. So if you like detail and you really want to come prepared for the interview, check out this video. All right, so in this video, I'm going to be going through a lot of information. And after I finish recording this, I'm going to put timestamps for each section. But I would highly recommend that you go through the entire video at least one time. And then if you feel like you need to brush up on certain things, or I may have gone through something quickly for you and you want to go back, hit up those timestamps. That should make it easy for you to navigate this video. But this is just in general what I'll be talking about. I'm first going to give you a little bit of introduction about me and my program. And my program might look a little bit different than yours, but that's okay. And then what to study to prepare for pharmacy school, time management, which is actually incredibly important, finding your niche or niche, mastering the classroom experience, and then pharmacy practice. So like I said, I'll put timestamps in the future. So here's a little introduction to me. Now I look like Shaggy right now because of the COVID-19, but I actually look like this guy, look like a young boy when I'm cleanly shaven. I grew up in California. I'm 26 years old, lived in California for 25 years of my life, but I decided, hey, I'm gonna go to Oregon Pacific University for pharmacy school, branch out. But I went to UC Davis. In my free time, I love watching horror movies. That's a badass picture right there. I do enjoy playing League of Legends, voice chatting with my friends, social drinking, hanging out with pharmacy students, all of that jazz. So that is what I enjoy doing. Now I want to talk a little bit about myself because I want you to take my advice in terms of me. Think of me as a friend who's gone through an experience, and now you're going to go through that experience. So I'm your buddy Mitch, and I've gone through the first year of pharmacy school, and I want to help you go through it swimmingly. So I'm giving you this advice. All right, so now for my program. And before I talk to you about this, I want to say that as pharmacy students, it doesn't matter where you go, we all have to take the same standardized test for pharmaceuticals called the NAPLEX. Now the NAPLEX, you take it once, you pass, and then you're a pharmacist. And you're technically a pharmacist in all states, but then for each state, you have to take a law exam called the MPJE. So for example, I want to be a pharmacist in Oregon, California, and maybe Washington. So I need to take 3 separate law exams in Washington, Oregon, and California on top of taking the NAPLEX. But what I'm getting at here is we're all accountable for the same pharmacy information. So even if my program looks different, everything else is applicable to you. So here's just a little bit about my program. Now your program is going to be 3 or 4 years depending on your school. Mine's a 3-year accelerated block program. And what this means is every 2 weeks we have a new block or emphasis that we focus on. So for example, one block might be cardiovascular, where we learn about physiology, drugs, all that. The next block might be cancer drugs. The block after that might be pharmacokinetics, but we're on this system. And we need a 90% or higher to pass. If you do consider going to, or you want to do a residency, I would recommend not going to a pass-fail college because it will make you less competitive. So if you do want to do a residency, try to go to an A, B, C sort of grading style, because that way your academics can actually differentiate you from other people. But there are other ways that you can get into residency even if you are in my program. That's just something that people don't like about this program. All right, so I go to Pacific University, which is, it's this building right here. And if you're curious as to why I picked this college, feel free to comment below. But this is what our block looks like. So on the Monday, we have SAS. Now this is your law class. Like I said, you need to pass the MPJE. But every day we have 6 hours of class. And it's really important that you pay attention during that time, but I'll get to that in the future. The next day we have pharmacy practice. Now I will talk about this more too, but pharmacy practice is essentially the class where you learn how to counsel patients, you learn how to, well, you learn drug devices like inhalers, eye drops, ear drops, and how to counsel patients on those. You learn over-the-counter medications, top 200 drugs, things like that. But then in your main block class, this is where you focus on the prescription pharmaceutical drugs. Like what are ACE inhibitors, what they do to the body, the side effects, the physiology of the body, all of that jazz, excretion, metabolism. Those are in your main block classes. And then for the second week, I go to pharmacy site. Now this started my second semester, but depending on your school, you might start this the first semester. So pharmacy site is where you actually go to a pharmacy, whether it's community or hospital, and you do things like you fill prescriptions, you learn how they, you learn their technology essentially. Every pharmacy uses a different sort of, I don't know, device, or I don't know how to describe it. It's like a program, essentially, like an internet browser thing for that. So that's your pharmacy site. And then on Friday, the block exam, where you get a 90% or higher to pass. But that's for my college specifically. So that's just a little about mine. But like I said, even if your class might not look like this, this is the gist of pharmacy school. It's a lot of class, it's a lot of studying, and it's a lot of information. And that's not going to change depending on where you go. But I just want to preface, everything I say after this point is going to be applicable to everybody. This is just my program. So now I'm going to talk about the prereq material that you learned from undergrad that actually keeps coming up in pharmacy school. And these are topics that people struggle with that I've noticed in my class. The first one is, well, I'm going to go through them individually, but dimensional analysis, unit conversions, equations, so algebra, you'd be surprised. Basic O-Chem, don't be scared, it's not a lot of arrow pushing. And then some Gen Chem stuff. But let's go through it one by one. With each one of these, I'm not going to teach you how to do it, but I'm going to give you an example of what it is, and then talk about how it's applied to pharmacy school. So for dimensional analysis, it's down here on the bottom. Essentially, how you do dimensional analysis is you're trying to find a variable in your answer. So in this case, it's how much solution in milliliters. So milliliters is the final variable. And we have to get to that by crossing out units. So in this question, the question gives us, IV infusion at 36 drops per minute, 3 hours, and then 15 drops per milliliter. Because we need mils in the solution, in the numerator, we're going to start with this right here. So 1 milliliter per 15 drops. And then we need to get rid of drops now, because we only want milliliters. So we're going to use this 36 drops per minute. So these cancel out. Now we have milliliters per minute. Well, we don't want milliliters over minute, we just want milliliters. So we're going to use 60 minutes per 1 hour to get rid of minutes. Now we have milliliters per hour, but in the question stem, they gave us over 3 hours. So now we can multiply by 3 hours to get rid of that, and just leaves us with milliliters. This sort of thought process of canceling out units until you find the right variables for your answer, dimensional analysis comes up over and over and over again. This is the most applicable thing you can study for pharmacy calculations and for other things related to pharmacokinetics in the future. So dimensional analysis is extremely important. If you try to just memorize formulas, it can be difficult because you're going to be overloaded with different formulas like, oh, do I use this formula for that? But dimensional analysis makes sense because you're using relationships and crossing out numerators and denominators and variables as you go, and everything adds up. So really make sure you know dimensional analysis. This is extremely important. All right, the next is unit conversion. In pharmacy, when we're dealing with drug concentrations, usually we work with grams, micrograms, and milligrams. So you should definitely know those, but I would say no deci to micro. We usually don't deal with nano and nothing up here. The only kilogram relationship we use is for weight. And because if you're living in the United States and you're using the metric, or you're not using the metric system, you always have to convert pounds to kilograms. So you're going to use this over and over and over again. Make sure you know it. This is probably the most common one. Length, converting feet to inches and then inches to centimeters. That's really important because a lot of the equations use kilograms and meters or centimeters to find the answer. So you really need to know how to convert that to the metric system. For the volume, teaspoon and tablespoon are probably the most common ones we use, but we don't even use these that often. Fluid ounce to milliliters, this is another conversion that I've seen. These, not so much. But those are the important ones. So kilogram to pounds, length, and then the top three here. Now I put this microgram up here because in pharmacy, we try to avoid any sort of confusion in prescription. So we use things like tall man lettering, where we'll capitalize parts of the drug name to emphasize them. But in terms of concentration, this micro symbol looks a lot like an M. So if a prescriber was writing this micro symbol and the pharmacist mistook that as a little m, this will be 1,000-fold higher concentration, and that could kill the patient. So in pharmacy, we do not use the micro symbol. We use mcg for microgram, and this helps eliminate any confusion. So that's just a little application for you. All right, this slide looks scary, and I apologize, but there's really not that much that you need to know here. You are going to have a class called pharmacokinetics, where you look at how a drug is essentially cleared from the body, and drug concentration in the body at a certain time is determined by these laws. So about 90 to 99% of the drugs are first order. So you are going to be dealing with this equation all the time. And the way it works is you have an initial drug concentration that you would give, and then you could solve for how much drug is going to be in the body after a certain amount of time if you know the K factor, and you can do algebraic or log manipulation here. So how that would look like is, if we look over here, the power rule is really the only log property you need to know, but you would take the ln of both sides, and then this negative kt is going to come out in front of the ln of a naught. Then you would solve for K or T depending on what you need. And if you remember from general chemistry, the half-life of a first order property is ln2 over K. And you might also see it as 0.693 over K. But you use this all the time in pharmacokinetics and this first order equation. So that's pretty important. Let me take a drink right quick. All right. So medchem, this slide probably looks really scary to a lot of people. I'm gonna break it down for what you need to know. Now I said before, you don't need to know arrow pushing. You don't need to know any of it coming in, but you might do a little bit of it in pharmacy school. I only had one block where we arrow pushed, and we only knew 2 or 3 mechanisms. So it was really easy. So you don't need to know any arrow pushing going in. What you need to know is functional groups. So for example, if we're looking at lisinopril, and we see this carboxylic acid over here, you should be able to recognize that this OH can be O minus, because this is an acid, and acids like to give up their protons to bases. So this could be neutral charge or negative charge. This right here is a base. This has a lone pair that can grab a proton. So this can be NHH with 2 attachments and be positive charged. So bases can be neutral or positively charged. If you don't know that, you need to focus on that for sure, because this whole acid-base relationship is extremely important in pharmacy school. And also pH versus pKa relationship. So when we're thinking of pKa, this essentially tells you how acidic something is. For example, if this has a pKa of 5 and this right here has a pKa of 9, this is more acidic because it's a lower number. Now, the importance in the pKa is not to tell you whether or not it's acidic, but it's to tell you how it functions in certain pH. For example, if this right here, pKa of 5, was in a pH of 1, the pH of the environment is more acidic than this right here, so the environment is going to keep a proton on this oxygen. Now, this has a pKa of 5. Let's say the pH of the environment was 7, like it is in the intestines. Because the pH is less and this is more acidic, this is going to function as an acid, so it's going to lose this proton and be negatively charged in the intestines. So that's why for acids, you have a neutral or a negative charge. For bases, it's the opposite. Because bases grab protons, if the base portion is in an acid environment, the environment's going to donate a proton to the base and it's going to make it a plus charge, right? If this is more acidic than the environment, it's just going to hold on to its H and stay neutrally charged. But this is never going to be a negative charge. So you should know how those relationships work. And in pharmacy, this is incredibly important because whether or not something can be charged will tell you if it's going to be soluble in an aqueous solution. If something has a charge, it's soluble in water because it can form different bonds with water essentially. But it also needs to be neutrally charged to diffuse across the cell membranes and be absorbed. So knowing the charge relationships and all that is extremely important for pharmacy school. Now here's just a little application. So if we're looking at this right here, this carboxylic acid could be negative. This right here can have a positive charge. And then if this was over here, this would be negatively charged, right? So negative, negative, positive. That has a -1 charge. Therefore, this cannot be absorbed in the body. What pharmacy does is they do an esterification, or they make an ester group for drugs, which they call prodrugs. And these prodrugs can be absorbed in the body, but then once they go to the liver, they get metabolized into an active drug. So this whole prodrug thing is something that you're going to see over and over and over again in pharmacy school. Lisinopril over here, and these are ACE inhibitors, by the way. Lisinopril has a negative, positive, negative charge. So it has 2 positives and 2 negatives, but overall it's neutral. So this can be absorbed in the body. So this is not a prodrug. This is an active drug as it is. And this is one of the only non-prodrug ACE inhibitors out there, on top, besides captopril. But that's just a little insight as to how this works in pharmacy. And I gave you a ton of information. You just need to know the functional groups, whether they could be negative, neutral, or positive, and also the pH versus pKa relationship. And I know I gave you a very brief description. If you need more insight on this, you should probably refer back to chemistry textbooks or online resources that delve deeper into this. But that's what you need to know for O-Chem. Now for Gen Chem, back to acids. There are different factors that pertain to how acidic something is. Resonance is one of them. If we're looking at this top left, where's my cursor? There we go. Up here, if we're comparing carboxylic acid to an alcohol, you may intuitively know that carboxylic acids are more acidic because you remember that from chemistry. But why they're more acidic is because when they donate a hydrogen to a base, the negative charge here can go throughout this system. It has resonance. It can be dispersed on this oxygen or this oxygen. So this is more acidic than this, because if this lost a hydrogen, the negative charge would only be on the oxygen, and that won't be very stable. So resonance is extremely important for determining acidity. Also, electron withdrawing groups. If we were comparing this right here to this, and we said which one's more acidic, this one's more acidic because these fluorines are electronegative and they're pulling electron density away from this system. So this system wants to lose a hydrogen to gain more electrons to put back in this system. So that's why electron withdrawing groups add acidity. So this one would be the most acidic. This one would be the second because this fluorine is the closest to the carbon. And then it would go to this one and then this one. And fluorine is more electronegative than bromine, so this would be more acidic than this one. And then, like I said, this is more acidic than this. Now, I sort of alluded to it here with resonance, but conjugate base stability also you can use this to predict acidity. And what conjugate bases are is they're what's left over after the acid has donated its proton. So this is an acid. The conjugate base would be if this H was gone and this lone pair was here. So if we're looking at conjugate base stability, which one is more acidic here? Well, if this lost its proton, this lone pair can go on this nitrogen, but it's not going to really do anything. It's not going to greatly increase the stability of the molecule. If this hydrogen gets taken up by a base, this lone pair can come into this system. And then if you remember Huckel's rule, it has 2, 4, 6. It has resonance here now if this loses its proton. So this is more acidic than this because this conjugate base with the resonance structure is stable. So that's why this is more acidic. Now this blurry photo on the bottom, this is just an example, but if this lost its proton, the negative charge would be on the oxygen, and there's nothing really too spicy about that or exciting. If this lost its proton and this had a negative charge, this can actually hydrogen bond to this, and that adds more stability than the negative charge just being on this. So this is more acidic than that. This is more of an obscure example of this whole conjugate base system, but that's just an example that we were exposed to in pharmacy school. Okay. You should know the intermolecular forces because a big part of drugs and what you need to know for them is whether or not they're going to be hydrophobic or hydrophilic. So you should know the more hydrogen bonding you have, the more hydrophilic it'll be because it can interact with water. So it's going to be more soluble in water. Van der Waals it affects basically all molecules because it's an interaction of electrons. So it doesn't say too much. And then electrostatic interaction is when the molecule has a charge. And like I said before, if it has a charge, it can interact with water and it makes it very aqueous soluble. So if we're looking at this, this could undergo Van der Waals. This, if it's an oxygen or nitrogen, hydrogen bonding, or fluorine, but usually we don't see that. This right here, F, Van der Waals, or hydrophobic interaction, hydrogen bonding, Van der Waals, hydrogen bonding. So you should be able to identify certain parts of molecules and what interactions may occur. So this is very important for not only predicting aqueous solubility, but also if you're looking at receptor interactions, because a lot of the drugs will bind to receptors. And depending on how in-depth you go for this, we only touched on it a little bit in my school, but receptors have certain amino acid groups on them that have things like OH molecules. And you need to know if the drug is next to that, how might the drug interact with that based on these intermolecular forces. So really get familiar with these. Lastly, I briefly alluded to it, but predicting solubility, if you have hydrogen bonding, this makes something more aqueous soluble. If you have charge, this makes it very aqueous soluble. But like I said before, if you have something that's charged, if overall it's neutral, it can be absorbed. If it's not neutral, it can't be absorbed. So charge is something you will grind into your head in pharmacy school. But right now, you just need to know how to identify hydrogen bonding. And then, like I said before about the charge, know if something can be neutral, negative, or positive charge. All right. So now I'm going to talk about less of the prereq material and more of the aspects of pharmacy school that people struggle with and things to make you successful. So I'm telling you right now, this is the most important aspect of pharmacy school that causes people to fail or succeed. Time management. You could be a genius, not study, and you'll fail because you don't know how to manage your time. You could go to pharmacy school not knowing shit, but if you have really good time management and you stay accountable for getting things done in time, you are going to succeed. So time management is extremely important. And what I noticed after I went through my first year, and I'm still in my first year technically, but if you stay consistent and you keep a consistent schedule, studying will seem less daunting. For example, every day I have 6 hours of class. After class, I study for 3 hours. Because of this, every day, because I study for 3 hours, it doesn't feel weird to me, and I don't get stressed out because it's the norm. And I would say as long as you incorporate studying into your life and you make it a normal thing, it's not going to stress you out. Now, I have some friends and colleagues who, because we're on a 2-week block system, they don't study until the second week and they get really stressed out because they're not prepared. So if you study and get into a rhythm and you find your niche or niche, then you will be successful. And the earlier you can get into your rhythm, the better. So really try to get into a rhythm as soon as possible. Figure out how you study the most effectively. For me, well, first off, when I went to pharmacy school, they tried to tell me that whatever you did to study before isn't going to work here because you're not going to have enough time. That's not entirely true. But it might not be the most effective way to study. So what I used to do is I used to rewrite all of the notes and organize them in a way that made sense to me. Now, I like to study with people and kind of go through topics one by one, organize them the way that makes sense to me. But then I emphasize certain materials more than others. So that's something that has changed for me. And I also study with different people. So my next point, surround yourself with people that you work synergistically with. There's this one guy that I study with who really likes details, and he likes to learn things that are outside the scope of the class, which is, it's good for him. It's like, I'm glad that you're passionate about it, but we need to know so much information. If you're trying to learn even more, then you're going to weigh me down because I don't need to know that information now. That's something I could learn in the future. So I try to not study with him too much because I don't want to get lost in the weeds. But there are times where I've taken exams and he would be like, oh, Mitch, do you know this and that? And I'm like, oh man, we don't need to know that for the test. And it was on the test and I got it right because he brought it up. So I can appreciate studying with him for that reason, but at the same time, it's not the most effective thing for me. So I have a different normal study group. Now, you need to make time for yourself. Staying mentally healthy is extremely important. Every day I wake up before class and I work out because I think I need to exercise not only my mind but my body. And trying to stay healthy and keep a positive outlook on life is extremely important for pharmacy school because if you only focus on school, you're going to realize that 99% of your life is school. And it's true. But try to have some hobbies, try to do things that you enjoy, and it'll make pharmacy school go a lot more swimmingly for you. Now Here's my little rant. Don't get involved in extracurricular activities unless you actually feel good about it and your heart's in it. Because a lot of people, and this happened in high school, undergrad, pharmacy school, a lot of people do things because it looks good on a resume. Don't do that, please. Do something because you're passionate about it and because you want to do it. Don't do it because you think it might help you in the future because it looks good on a resume. Because at the end of the day, if you go to, let's say you go to Africa and you build a home, that's great and all, but if you didn't learn anything from that experience, does it really mean anything? That's the whole point of this. If you go through an experience and you don't learn anything from it, but you do it because it looks good on a resume, then you're wasting your time. I'm telling you right now, you are not going to have a whole lot of time in pharmacy school. So only do things that you feel good about and that you want to do. For example, in my schooling, I had the intention of joining a ton of clubs, maybe a frat, but then I realized that there was a huge obligation for time. And even though during my first block, it felt like I had a lot of time, if you invest your time into something, down the road, you might feel obligated to go to events that you have to, or something like that. And if your curriculum gets harder and you have that time obligation, now you're screwed because your classes are really hard. You may have finals depending on your program, and now you have to go to a frat event and you lost a whole day of studying. You don't want to do that. So when you're thinking about joining organizations, doing things for the community, you need to think about, is my heart in it? How much of a time commitment is it going to be? And how is this going to affect me down the road when I'm thinking about future obligations, if you're going to be tied down to an organization or something like that? All right, so that's my little time rant, or my little rant about because it looks good on a resume. Do things that you feel good about. And like I said, time management is really important. Don't ever forget that. This is the one thing that you need to focus on when you're in pharmacy school. All right, now, if your program's anything like mine, you have lecture for 6 hours a day or so. And during this time, in undergrad, you might have felt like going to lecture was a waste of time and that you felt obligated to go. In pharmacy school, you need to go to lecture and really be prepared and focused to learn information. Now, you don't need to know all of it. You don't need to go to lecture thinking, oh, I'm going to remember 80% of what I learned today. That is highly unrealistic. What I do personally is I go to lecture and I try to take away big picture ideas. So what did the professor emphasize today? If we're talking about hormones, what are the different hormones that my professor talked about? How are they different, just in a general term? And then later on, I might go back to the information and read about all the drugs and say, what do the drugs do specifically? What are their adverse effects, mechanisms of action, things like that. So when you go to lecture, it's unrealistic to try to get everything out. But you should come prepared and focused and stay well caffeinated. As you see, I'm staying well caffeinated right now. Staying mentally sharp to hit you with that raw information. In pharmacy school, it's a little different than undergrad because you're going to have a ton of different professors that are pharmacists specialized in different aspects of the field, or you might have researchers giving you information. Right now, I think I've had about 10 to 15 different professors, and next semester and the second year, I'm going to have about 10 more new professors. But what I've noticed is when I have these different professors, I go to lecture with the intention of learning, what is this professor emphasizing? And I take notes on that. And if something's not on the exam and they say, oh, this is just for your information, then I write that down. This is just FYI, not on the exam, because you are going to get a shit ton of information. And when you're referring back to your notes and studying, you really want to know what's going to be on the exam and what's not, because you're not going to be able to remember everything. It's just too much information. So be selective, learn what each professor emphasizes and what to expect on the exam. So after your first exam with them, you're going to have an idea about their style of questions, and that'll help you study for them in the future. So yeah, take notes selectively, listen to understand big picture ideas when you're in lecture. You're not going to know all of it. And always attend lecture. Now, I alluded to this earlier, you always want to attend lecture to know what is and what isn't on the exam. If I miss a day of lecture and they give me 120 slides to know, if I don't go to lecture, I'm not going to know that 20 of the slides aren't on the exam. They're not exam material. I'm not going to know what to focus on for each slide. Because usually they might give me a slide that has, let's say, 10 things of information, but only 2 or 3 of them are exam-worthy material. If you don't go to lecture, you're not going to know that. So you're going to have to overstudy because you didn't want to go to lecture. So always attend lecture, please. And then know when not to attend review sessions. If your program is anything like mine, you're going to have a review session for each professor that taught you for that block. And they always organize them differently. Some of them do Q&A, some of them do comprehensive reviews of the material. If you feel like you don't know anything about that block, then you should go. Because a lot of people are going to ask what I like to call basic questions that you could probably look up and figure out on your own. But if I have a question and if I know all of the material on the slides and my question isn't answered by that, then I'm not going to make a big deal to go to these sessions to figure out the answer to my question, because I'm going to be spending 2 hours or 1 hour in this review session and my question might not even get answered. So really know when review sessions won't be helpful for you. Some professors emphasize material that will be on the exam in review sessions. So if you want to go to a review session, I would highly recommend going to a review session like that. And how you can determine this is go to at least one review session for each professor, see if it's helpful or not for you, and then after that, determine whether or not it's worth going back. But yeah, that's really important. Know when not to attend review sessions. You have a limited amount of time in school. You don't want to spend it going to a review session. That's not going to be helpful. All right, what I do the night before and on exam day. If you're anything like me, you get stressed out for exams. Now, I don't really get stressed out physically, but subconsciously, I will not sleep the night before an exam. So I drink NyQuil, and I get 8 hours of sleep. I come to the exam fresh, feeling good, have that long-term memory, and I'm chilling. On the exam day, I go to Starbucks, and the first time I ordered this, I was like, yeah, can I have the liquid cocaine? And the dude looked at me and he's like, we don't sell that here. It's like, all right, well, can I get 4 shots of espresso with 4 pumps of white chocolate syrup? It's important to stay well caffeinated for the exam, but at the same time, you don't want to drink too much liquid to where you have to piss yourself, and you don't want to drink too much coffee to where you're going to have a bowel movement in the middle of the exam. So I like this personally because it's only 4 shots of espresso. I'm not getting a whole lot of liquid in me, but I'm getting a lot of caffeine. If you don't need caffeine, then don't worry about it, but this is my go-to. All right, now the pharmacy practice. I'm going to spend a little bit of time talking about this. This is a class that you're going to take. This might be, for sure, you're going to have a class on this, but they might make you held accountable for like the top 200 drugs on your own. But essentially, pharmacy practice is where you learn about over-the-counter medications like Tylenol, Benadryl, things like that. You have to know how to counsel patients on this medication, also on devices and on prescription medications. You do calculation problems. This is where dimensional analysis always comes in. Almost every question has dimensional analysis. So know that. That's very important. And then the top 200 drugs. And when you start pharmacy school, you'll also notice that you have access to online drug resources as a healthcare professional. And this is things like Micromedics, Lexicomp, but essentially what they are is you type in the name of a drug and it tells you everything about the drug in certain sections. And this is incredibly important. You'll get more information about this in pharmacy school. but this is just an aspect of it that I think is really important. Now, if your program is like mine, then your class is going to be jam-packed with a ton of information, and you only have it once a week or less, depending on your curriculum. And I'm going to talk a little bit about what my curriculum looked like for that. This is the hardest class in terms of time management, because you have a ton of information and you don't have a lot of time to actually study for this. So like I said before, most of your time is going to be in your block class. But this information you are held accountable for, even if you don't have class on it. It's like an elective that you have to do and be responsible for. So it's a difficult class. Now, here's an example of what I learned the first semester. So the top 200 drugs are drugs that you commonly see in pharmacy. And for these 200 drugs, you need to know, this is an example of one of them, but the class it's in, the mechanism of action, the generic and brand name, the dosing range or dose, side effects, counseling points, contraindications, black box warnings, additional notes. You need to know a lot for these 200 drugs. And in my first semester, I need to know 120 of these. And this isn't the only part of the class. We also had to do RX verification. So we had to know whether or not a dose or a prescription that a prescriber wrote would be appropriate for the patient, and if it's okay. We had to know how to take blood pressure, heart rate, and how to counsel on it. We had to do over-the-counter counseling, and we had to know calculations. Now, over-the-counter counseling, these are the topics that we covered, and it looks like not a lot, but for each of these, we had to know what over-the-counter products were appropriate, what non-pharmacological products, like for insomnia, it was try to go to bed at the same time every day. Make sure the temperature in your apartment or house is 68 degrees. Things like that. Don't drink coffee 3 hours before you want to go to bed. Don't eat 2 hours before you want to go to bed. We had to know all the nooks and crannies of these topics, and then we had to counsel patients and then pick from this and know about these and which one would be the best for the patient. For example, if the patient came in with allergies, they were like, yo, pharmacist Mitch, got bad allergies, I want to take something, what could you recommend? Well, we have Benadryl allergy, Claritin, and Zyrtec. If I'm looking at Benadryl and Zyrtec, I would say, well, are you going to take this at night or in the morning? Because Benadryl can tire you out, it's sedating, but Zyrtec isn't. So if you're going to take it in the morning, take Zyrtec. If you're going to take it at night, take Benadryl. And I actually popped a Benny the other night because I have a terrible rash on my foot right now. It's really itchy. So that's just something that we would do in this class. We use a mechanical arm that's standardized for blood pressure and heart rate. You may or may not do this, but you need to know how to put the cuff on someone's arm. And yeah, what else do I want to say about this? The top 200 drugs really creep up on you. In the future, if you're going through this PowerPoint and you're like, how does Mitch do this? How does he learn all this stuff? As you're going through your block classes and you're learning about drugs, I would look at the drugs like we talked about lisinopril. If I'm learning about lisinopril and I've already been exposed to it on the top 200 sheet, I'm going to go to this sheet, look for lisinopril, and I'm going to see if all the information makes sense. Because in your class, your pharmaceutical class, you're going to learn about side effects, dose range, generic and brand. You're going to learn a lot of information about it. And then you can make these connections once you've done that. So try to link your classes together. Now, one common misconception, and I actually looked at other videos to see how people were giving advice on this. They said you had to be a pharmacy technician to go to pharmacy school. That is completely incorrect. You do not need to be a pharmacy technician. But the one thing that pharmacy technicians do have an advantage of over other students is they're familiar with generic and brand names of drugs and what they're used for. So that's what pharmacy technicians know over just regular only students. But you do not need to be a pharmacy technician. I've never worked in a pharmacy, and I'm doing well in pharmacy school. So don't let that discourage you. And also, you don't need to take microbiology. I do not know where that, or biochemistry. I don't know where this came from, but you learn the biochemistry when you're in pharmacy school. So don't let other people's advice and misguidance steer you away from pharmacy school. All right, so this is the first semester. The second semester, and let me just, before I move on, I had this class once a week, okay? Second semester, 80 top 200 drugs. We still had to do RX verification, blood pressure, heart rate, OTC counseling, calculations. But the OTC counseling, we added even more information. So we had to know like twice as many over-the-counter drugs. But now we're adding prescription counseling, eye drops, eye ointments, eardrop counseling, 4 types of inhaler counseling, glucometer counseling, and then DI, drug information response. We have to know so much more the second semester, and we only have this class once every 2 weeks. So we have this class twice as little as the first semester, and we're given exponentially more material that we need to know. This is why you should not fall behind, and don't take your free time for granted your first semester, because everything's going to build on itself and it's only going to get harder for you. So really try to get ahead of the game, try to be consistent and get into a rhythm quickly and figure out what works and what doesn't for you. Because if your program's anything like mine, it's going to come very fast and you're going to be overloaded with information quickly. So make sure that you're prepared for it. Try to get ahead of the game. I'll just talk a little bit about this stuff. So like I said, all of this is the same. OTC counseling, we had more stuff. Prescription counseling, we basically used all of the information that we learned from our block classes with the prescription drugs, and we're applying it to counseling. But we have to ask things like, oh, well, what did your prescriber tell you about this medication? Or how this medication should be taken, what to expect from it. We implemented aspects of it like that we hadn't before. This part wasn't that bad. Eye drops and ointments, eardrops, inhalers, glucometer, and DI. This is actually fun. We get to learn how to use these devices and then teach people how to use them. And I think this is a very useful skill to have as a pharmacist. The DI response, this is where you get here's an example. They give you a simulation where a doctor sends you an email and is like, hey, pharmacist Mitch, my patient's kidneys are failing and here's their stuff. Are the drugs that they're taking right now appropriate for this patient? And then I would use Micromedics or Lexicomp or one of those drug information resources that I talked about earlier to solve this problem, and also my pharmacy knowledge. And I would give the doctor a recommendation. That's what DI responses are. And your school may or may not have you do this. I'm not entirely sure if it's mandatory, but it's pretty interesting. It's like solving a puzzle. So yeah, this is pharmacy practice. Now, just to wrap everything together, and I'm not going to talk about rotations because of the whole COVID-19 thing, I've only had three or four pharmacy rotations where I actually went to a site and got experience. So I don't really have a lot of knowledge on that, but maybe in the future I'll talk about that. But just to wrap everything together with a summary, time management is the best skill you can practice to succeed. So know time management, know how you're going to allocate your time, know that repetition is key, get into a groove quickly, and try to stick with it. If your school offers you a readiness program with prereq info, do it. So I gave you a little bit of prereq info here, and this is the info that keeps coming up in my program. But if your pharmacy school gives you a readiness program or prereq materials that they want you to know, you should definitely take a look at it and get familiar with anything that you're not aware of or comfortable with. Keep a consistent schedule and stay mentally healthy. Talked a lot about that. There's a lot of info. Don't fall behind because it only gets harder. Gave you a perfect example of that with my first and second semester. Get comfortable with the pace of your program before you join multiple clubs and become involved with extracurricular activities. Like I said before, only get involved in things that your heart's in. I like interacting with people, so I became a student ambassador for my school. I'm really into research, so I got involved with Journal Club. That's an example of mine, but only get involved with things that you feel good about. Don't do it because it looks good on a resume, please. That's so cringy. And last, this is not undergrad. You've gone to school for a long time, and now you're going to school to be a freaking professional in the field of pharmacy. This is going to be your life. You're going to school because you want to be a craftsman or craftswoman in pharmacy. So really do not take your education for granted. You're paying a lot of money to go to pharmacy school, and you're investing even more time to master your craft. Don't ever forget that. Treat your school as a vector to becoming the best pharmacist that you can be. And I can't emphasize that enough. Don't go to class because you have to, go to class because you want to. And if you ever do find yourself falling behind in pharmacy school and stressed out, I would say just remind yourself why you wanted to be here in the first place. If you love helping people, use that to fuel the fire for you to get through pharmacy school, bust your ass, really learn this information, and be a great pharmacist. With all that being said, it's been a pleasure. Thank you for sticking with me. And if you have any questions, please comment below and I'll get back to them as soon as I can. Thank you.